if I can record again. Okay. So what I want to do is I want to list out all the possible factors of P of 4. So first thing I'm going to do is look at what are some factors of 12. So, oh geez. So let's see. I could do x minus 1, x plus 1. I could do x minus 2, x plus 2. Do x minus 3, x plus 3. That is not a plus. Let's see, 4 divides it. X minus 4, x plus 4. 5 doesn't divide it, but 6 does. X minus 6, x plus 6. And then 12, x minus 12, x plus 12. Okay, so now we've done all the possible factors of 12 using 12. Now we need to go back through that list and add in 3 as a possibility of a factor of x. 3, 3, 3, 3, 3, 3, 3. I'm gonna stop saying 3. Oh.
Wait, why are you doing that?
Because for the rational root theorem, and I'll pop that on the screen over here too. Sorry. Okay, so the idea is that the possible rational zeros of P of x are right here, are in the form of factor of 6 divided by factor of 2, because 6 is the constant and 2 is the leading coefficient. So the factors of 3 are 3 and 1. So the first ones have the 1 in it. And the second number are all factors of 12. Now, this is a list of 2, 4, 6, 8, 10, 24 possible factors. It's crazy to try to go through and test each and every one of them. And by crazy, I mean not worth your time. It's inefficient to test every one of those. Plus, some of these are exactly the same as other ones. Like some of these are redundant. Like 3x minus 12 is the same thing as x minus 4 if you factor 3 out of it. So some of these are redundant. So I'm not going to cancel out the ones that are redundant, but I see that these are all the possible factors. What I'm going to do now is I'm going to sketch this because 24 factors is way too many for me to even start trying. I'm just going to say on a scale of 1 to 10, nope, 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 nope. Plus 10x squared. Again, we're trying to maximize our time and be efficient. Here's the graph. So there's three roots. And I went and clicked on them to try to figure out what they might be. So I'm going to minimize this a little bit. All right, so a couple of those I don't recognize immediately, but the one I do recognize right away is 0.667. That is 2/3. So that means this one, 3x minus 2, is a possible factor. So then what we can do is do polynomial division and see what's left. Because then once I get a quadratic, then I can do some more stuff with it. And honestly, I'm looking at those other two and I'm like, that's probably the only one I can do. So if I was gonna go do this without a sketch, I would have gone through all of these first 12 before I would have started this one. So I would have gone through 14 before I got to this one. That's why it's important to sketch to make your life a little more efficient. I'm gonna go to a previous slide, grab this, because I don't want to remake it. Put it right there. So I'm gonna put 3x right there. And -2 right here. So the next thing that should go in is I'm going to take 3x cubed and put it in this box. So 3. Which 3, that means this needs to be x squared up here, because 3x times x squared will give me what I need. X squared times -2 is -2x squared. I need the x squareds to add up to positive 10x. So I'm going to duplicate that, which means this probably needs to be positive 12x. Right? Yeah. And 3x times something gives me 12x squared. So this should probably be 4x. Oh. Yep. Put it down there. 4x times -2 is -8. If you see me do a number wrong, holler, because I'm definitely possibly making a mistake. So let's see, -8 plus something gets -26. 18? Yeah. Let's see, 3 times what gives me -18? Or is that -6? I think that's -6. And then -6 times -2 is -12. Or positive 12, which is what it needs to be. Sweet. Now that I have a quadratic, this piece right here, now I can use the quadratic formula on that, and that should give me these other two roots. That should give me these other two numbers here. All right. I'm going to stop recording from there, because then I could just say my two roots of this, or my two factors, are this quadratic and this linear one, and call it a day. But if I want to know what the roots are, then I've finished using the quadratic formula on this bad boy. Okay. And that's that.